Welcome back, everybody, to the Rule Your Pool podcast. This is part 2 of our Green Pool series, episode 26. Jared Morgan, president of Orenda, thanks for being with me once again.
You just had to say it, didn't you?
I had to. Well, previous episodes, you were thanking me for being here. But, you let me open these up and say the first few words. I'm going to have the advantage.
Okay, fine. I'm here.
Okay. So in the last episode 25, we talked about why is my pool green? If you have a green pool, hopefully you learn some things. There are basically 3 reasons that your pool is going to turn green. One of them is an imbalance of too much alkalinity relative to your calcium. As we said in the last episode, we still don't know the exact chemistry of why that is. We just know that it is. And you can correct that. And we're going to describe that in this episode today. The second reason, Jared, was
copper.
That's right. And we'll discuss how to fix that as well. And of course, the main one is algae. So without further ado, episode 26, this is how to fix a green pool the Orenda way. Let's go. Welcome to Rule Your Pool, the podcast by Orenda that explains and simplifies pool chemistry so that anybody, regardless of experience, can understand it. I'm your host, Eric Knight, bringing clarity to these subjects so that you can bring clarity to your water. If you're ready to rule your pool, then let's go. Okay, we'll start with the easiest one here. It is becoming more common, I think, Jared, that we are seeing more and more of these pools that are turning green just because there's not enough calcium in the water. So I think the fix is pretty simple. You want to remind the audience of how you helped that one homeowner, and I'll remind the audience of how I helped the commercial pool.
I think we can keep this first 2 pretty short and sweet. And on the first problem with having a calcium alkalinity imbalance, all we did was raise the calcium level from 90 parts to 260.
Now, when you added that calcium, did they use SC1000 to chelate that calcium before they added it?
I hope so. I cannot honestly answer that question, but it is good practice to chelate your calcium before adding it to any pool.
Okay, so on mine, the commercial pool I was telling you about, they did. So they used SC1000, but they didn't purge the whole pool with SC1000. It was like a 260,000 gallon pool. They didn't put in 5.5, 6 gallons of SC. They actually used only about half a quart. And the reason was they only put a little bit into each bucket when they were pre-dissolving calcium, and then they put in the acid into the same bucket so that they could lower their alkalinity while simultaneously raising the calcium with chelated calcium. And as the customer said, you could literally watch the water turning from green to clean in a matter of minutes. It was a pretty amazing thing. I wish I had a time lapse. Now that I have a company GoPro, maybe I'll put one in next time I come across a pool like that and do an underwater time lapse of how it cleans up. It's pretty amazing. But that's basically all you need to do. You just need to get your calcium and alkalinity in line. We have found that a 3-to-1 ratio is a great target. So, if you've got 100 alkalinity, you need at least 300 calcium, or bring your alkalinity down. Get that alkalinity down to 80, especially if you're on a salt pool or a liquid chlorine or cal hypo pool. In the summertime, you're not going to need 100 alkalinity. That's too much alkalinity to begin with for other reasons. And we've talked about that in previous episodes and probably future ones as well. Anything I'm missing on that one, Jared?
Nope. What about number 2?
Number 2 is copper. So the first thing you got to do is figure out where the copper is coming from. So if you've done the white bucket test and you added a little bit of chlorine and the color got darker, that tells you have copper in your water and it is oxidizing and turning green. So where's it coming from? Did it come from copper algicides? Did it come from a mineral system or an ionizer that had a copper? I guess I'm trying to think of like copper structure. I guess it's a piece of literal copper that runs electricity through it. Is that how I don't even know how they work, Jared. Why am I even talking about this?
What, copper ion systems?
Yeah, I mean, we know they're a thing. I guess I've never actually taken the time to learn how they operate.
You know what? Shame on us. Sounds like we got another blog coming out.
Hold on. Is that shame on me or shame on us? Because I feel really good if I'm not alone in this.
Let's just gloss over that real quick.
Okay. All right. Audience, you got one over on us and we didn't even ask for it. So, well, at least we're not blowing smoke at you because we don't know everything. And it sounds to me like we need to do some homework on that. We do know they're popular. We understand how they sanitize that part, but how they actually deliver copper into the water, I've never actually taken the time to look. So I guess I've just assigned myself some homework.
God, way to bring up all the stuff in the closet that we don't know.
All the deficiencies in our thinking. But anyway,
Well, moving on.
Yeah. Where did the copper come from? Now, normally it's going to be from an algicide or from your heat exchanger. And the first thing I'm going to say, if it's the heat exchanger, figure out why. What is corroding that heater? Normally it's going to be a low pH or low LSI in general. It doesn't have to be a low LSI if the pH is low enough for other reasons. And you could also have galvanic corrosion. Those are other issues. But typically, the most common thing that we see is people putting too much acid in their pool at once or column pouring it. So it goes straight to the bottom, into the main drain, right through the circulation system at a low pH. Jared, you've seen that happen before, right?
Or adding chemicals through the skimmer.
Like trichlor tabs in the skimmer, or
that's
worse.
Probably the number one culprit right there is trichlor tablets in the skimmer, continuously pulling that low pH water into the pump and going straight through the heater.
Yeah, trichlor is about a 2.8 pH. Let's round up to 3. And a 3 pH is 10,000 times more acidic than perfectly neutral water. So you're putting a very acidic solution directly into the main vein, and it's going to go through and it's going to destroy a heat exchanger. So be wary of that. I would say the most common thing we see is a heat exchanger. The second most common is from copper-based algicides. Would you agree with that, Jared?
Yes.
All right. So cut that off, figure out what that is, stop the source, and then you can address the metals. Okay. Now, full disclosure, Orenda, we make SC1000, which is a chelating agent. It is not the best thing at lifting stains. That's not what it's made to do. It is not a stain removal product. It can help, but it's not what it's made to do. It's not a metal removal product either. Okay. It's a chelating agent.
It needs to be used in conjunction with a citric acid or something to help lift stains off the surfaces.
Right. And if it hasn't even stained yet, if the water's just tinging green at the time, which is, it's possible, SC1000 can actually clear it up pretty well if it has not fully formed a stain. I don't know if my vernacular is correct there, if I said that correctly, but
makes sense.
Yes, SC1000 can clear that up, but you need to be aware that if you're purging with SC1000, it will wipe out your chlorine to 0 in the short term. So
please don't try to raise your chlorine until day 3 or 4.
I've had at least 2 days. Yeah, day 3 is probably appropriate.
Man, I've had customers call me all the time and they say, wiped out my chlorine. I've been adding gallon after gallon of bleach. And I'm like,
right,
it's not going to happen.
Well, that time that it takes, we could do a whole nother episode of why SC1000 wipes out your chlorine, but basically chlorine's attacking it, and SC1000 is invulnerable to chlorine. So you're actually losing chlorine attacking SC until it binds to a metal or mineral. So it basically just needs time to do its job. And the warmer your water, the faster that happens. So, if your water's 85 degrees, well, maybe you can add chlorine the next day or 2 days. But if it's 60 degrees or 70 degrees, it might take 3 or 4 days or longer. So just be aware of that. We recommend initially putting SC1000 in during startup because you haven't chlorinated yet, but that's another topic for another day. The point is SC1000 is not made to remove metals from solution. So if you are trying to get the copper out of your water, which we recommend, you need some sort of copper filter. You need some either filter additive in your filter or a metal removing filter. I know they make some that you can put in a skimmer basket or a strainer basket. Those are very, very effective products. They can be used in conjunction with SC1000, but SC1000 alone will not get copper out of your water. Okay. It's correct. A chelant. It is not a sequestering agent. It's not a metal removal. So just want to set expectations there.
Number 3.
Number 3. Go ahead, Jared.
I was going to say, first, I want to stop right here. And
this is why you're leading this part, because we have to be very careful and tiptoe with how we word this.
Well, we do have to be very careful because the bottom line is, everybody, chlorine is the best algicide for your pool, period. You can have chlorine in there. It'll kill algae. It'll kill viruses, kill bacteria. That is what its job is to sanitize and keep your pool clean and safe. All right. So anything we're going to talk about in this episode, it involves chlorine as the algicide, doing the heavy lifting, killing this green pool to make it clear. Okay. Mm-hmm. All we want to do is try to make that chlorine more efficient. All right. So it has an easier time doing its job. And if you've listened to this podcast enough times and you've seen our marketing and our blogs, you know we are about proactive pool care, making chemicals more efficient, and less is more, right? So that's the way we're going to kind of take this third step of algae, green pool cleanup type situation. We're leaning all the way on chlorine to do the heavy lifting.
Mhm.
And it's our job to do anything we can to make it more efficient and better.
Right. Well, that's a very good preface. We do have to be very careful on it. As a chemical manufacturer, there are a lot of people that claim a lot of things out there. We are very responsible in the sense that, number one, we obey the law, and what you can and cannot say needs to be observed. Number two, we don't want to set false expectations to begin with. There's a lot of snake oil things out there that can promise to be the best, best chemical that can do all sorts of stuff. And we find that rarely to be the case. Typically with us at Orenda, the procedures matter more than the chemical themselves. Would you agree with that, Jared?
Absolutely.
This is a process. So hear us out on the sequence of how to do this. Okay. It's not so much product specific, it's sequence specific. And I'll explain why. So as Jared said, chlorine, specifically the killing form of it, hypochlorous acid, is by far the best algicide there is. I mean, there's nothing even close to it. The problem is, especially in a stabilized pool with cyanuric acid, you don't actually have a lot of that available. Okay. But I mean, it will come available once it unbinds from cyanuric acid. But if you have too much CYA relative to your chlorine, this is a much slower process. And as we said in the previous episode and many other previous, like episode 23, sanitization is a race between the killing speed of chlorine and the growth and reproduction rate of the living contaminant like algae. So the slower your chlorine, you're going in with a disadvantage right out of the gate. And if you're fighting an outbreak of algae already, well, algae's already got the lead on you. So not only do you have to catch up to it, you got to stay ahead of it. Okay. Am I safe so far, Jared?
Yes.
Okay. HOCl, hypochlorous acid, gets used up on a lot of things. Okay. It's just going to kill or oxidize whatever it touches. So it can't just focus all of its energy on germs and algae. If there are oxidants in that water, it's going to oxidize.
We like to
what
call
touches.
it a non-specific oxidizer or non-specific sanitizer.
I've never heard you say that ever again. Say that again. You like to call it that. I've never heard
Absolutely.
that.
When I tell people that all the time, chlorine is dumb. It is a non-specific oxidizer. It's going to try to oxidize whatever is in its way.
It is an equal opportunity destroyer. That's for sure. Anything it touches, it'll attack pretty much.
And iron happens to be really, really high on that list.
Oh, well, it's the easiest thing for it to oxidize. So
yeah.
That all being said, there's a lot of things. Nitrogen compounds takes a lot of chlorine to combine with it. Another episode for another day. But the point is, it gets distracted, Jared. There's a lot of things that chlorine has to do. And so we can't just force chlorine upon algae alone, because if it could, we would never have green pools to begin with, because typically you'd have enough chlorine that can handle it if it didn't have all of these other non-living oxidants to handle. And of course, the major one there is bather waste, non-living organics. That's the whale. That's the 800-pound gorilla. And these are the bather products that come from our bodies. The natural ones like mucus and stuff. We discussed this in episode 22 about non-living organics, but it's bather products, body oils, lotions, deodorants, and of course, sunscreen. Chlorine is going to get used up on that stuff if you're not supplementing your chlorine against it with something like a secondary oxidizer system or enzymes. But once we get all that out of the equation, the real question here is a race. Like we said before, how fast can chlorine kill this stuff? Right? I mean, Jared, that's really what it is. Can it kill it repeatedly faster than it can reproduce? So, Jared, you come across a green pool. I've got one in the background here. And for those of you listening, it's this swamp green pool behind me. And there's a white cloud going on. And we'll explain that in just a moment. But you come to a swamp pool, Jared. You've come across several in your life, I'm sure.
We did one this week.
Oh, did you now?
We did.
Okay.
Because here in Texas, we had our nice freeze and it put a lot of pools out of commission and a lot of pools are turning green. And we got one back up and running on Friday and it was a green pool.
Okay. When you come to a pool like that, before Orenda, go back several years when you were just starting out here, what would you have done? What was the normal protocol to address a green pool?
man, I hate admitting it, but it was kind of what everybody did at the time and probably still does, honestly. It was superchlorinate, drop pH, and throw in a pool that you have to follow it up with a big dose of chlorine to help with the algae.
Throw in a pool? What did you mean?
Well, when you throw this chemical in a pool, it tells you to throw chlorine right on top of it.
I don't know which chemical you're referring to, but I'm assuming it's an algicide.
It is.
Okay.
Yeah.
So most of the time, the strategy has been, I got a green pool, we got to nuke it. For lack of a better term, we're going to super chlorinate it and we're going to throw an algicide on it. And we're just going to throw the entire kitchen sink at this problem. And then you come back the next day, Jared, and where's your chlorine?
No chlorine.
Level?
I mean, it's zero.
Well, it can be a little more than zero, but usually it's pretty dang close to zero.
Yeah. No, when you have a green pool, it's zero. I mean, you come back and there's just nothing left.
Okay. Why?
Because the chlorine ran through its residual, oxidized, sanitizing the water, and it just did not have enough to push through the demand.
In other words,
in our terms right now, not now knowing what I know, that's the reason. But 10, 15 years ago, I was just frustrated because I was throwing, 5, 8 pounds of shock in a 20,000 gallon pool with acid and algicides and nothing. It was helping. Don't get me wrong. It was doing something.
The water, it would be a lighter shade of green. Or
it was like a kind of a bluish, greenish, cloudy pool.
It was still a mess.
Yeah. It took multiple days to clear this thing up.
Well, I'm going to explain what happened. Okay, now you know now, but for the sake of the audience, basically, you killed multiple generations of algae. You had plenty of chlorine without the algicides. Okay, you had plenty of chlorine to kill every bit of algae in that pool, but the problem was it had so much nutrient levels in the water. The water was warm enough, the conditions were right, that this water was eutrophied. And we explained eutrophication in the previous episode, but you basically had optimal growth conditions. So you killed that first generation of algae. It releases its nutrients when the cell walls break down and die. And then the next generation scoops them up and forms the next colony of algae. And then you kill that. And then 3 to 6 hours later, the next generation forms and you kill that too. And so by the time you come back the next day, you could have killed 4, 5, 6 generations of algae, depending on the conditions. And now you're out of chlorine. The other thing is, if you don't get physical debris out of the pool, like piles of leaves or pine needles at the bottom, that's the big one, that stuff can protect and shield a whole bunch of algae that is under those piles or within those piles. I've run into the problem where we almost get it completely cleaned, but because of a pile at the bottom, it's not quite there. And on the second day, we did that kind of riptide vacuum thing, got as much as we could. We thought we got everything out, Jared. I mean, I took scoops and brushes and we just scooped and scooped and scooped, netted so much debris out of the bottom of this neglected pool. The next day, we could see into the water about 3-4 feet, but we couldn't see the bottom. We scooped more, and I bet it would have almost filled the bed of my F-150 truck. That was the second day's load. And it just goes to show that when you're scooping, you got to go slow and controlled, because if it's a really neglected pool, if you move fast, it's kind of going to float around on you. So you don't feel it on the bottom anymore and you don't get full scoops. That's what happened to me. It's happened to me twice. I'm not going to let it happen to me a third time.
I will say,
you got to get debris out.
There is a point when you're in the service trade or a homeowner or whoever it may be, where if it's neglected enough for a half a year or a year, call it, and you've had a fall and a spring worth of leaves falling into it and decaying and sitting there, and you start getting tadpoles and frogs and snakes and things in it. At that point, it's time to drain it, and you probably need a professional to help you out here so you don't float a pool, especially when it rains a lot and the water tables are off.
That's not a probably. If you're going to drain your pool, you definitely want a professional to do it, because you want the insurance. Because it is, if you float your own pool, your insurance probably isn't going to cover that. Is that a fair statement?
We've flooded a house before by hooking the discharge from the drain, from the sub pump to the, we actually hooked it up to the backwash line, and it backed up into the house from the garbage disposal and flooded the entire house.
Oh my gosh.
So please be careful.
Have a
Don't do this
professional
on
do
your own.
this. Get a waste pump. It's going to be nasty. But Jared's absolutely right. I mean, if it's a complete cesspool with, you know, lily pads growing in it, drain it, get it professionally done. It's not worth the stress and time. I'm talking more about green pools that have flipped in the last couple of weeks,
Yeah, they're
not the
clear.
last 2 years ago.
You know, there's not a year's worth of leaves in them. If it's just, some leaves and some stuff in there and we can flip it chemically, absolutely. This is the way to do it.
Mm-hmm. Now, when you come across a green pool, you're going to notice a few things. Number one, if you just throw chlorine to it, like liquid chlorine or especially Cal Hypo, it's going to really cloud the water. And I learned this when we first tried to do the green pool cleanup procedure, which you can find at procedures.orendatech.com. Threw in a whole bunch of Cal Hypo and, pre-dissolved it in a bucket and everything. And it went in and just put this white film across the whole top of the water. And I'd never seen that happen before. I know it sometimes clouds water, but this didn't just cloud. I mean, it's like the calcium never went into the water at all. It
You
stayed
can
on the
actually
surface.
almost see the granules of Cal Hypo floating on the top.
No, I did see them. I absolutely did. I've got photos of it. And the reason was the pH was way higher than we could measure. And I thought, okay, it's probably in the 8 something. And this was before we understood Henry's law, where the amount of CO2 in your water determines your pH. Well, not literally, but it basically does for practical reasons. Algae eats CO2 and it takes it out of solution, just like it takes other nutrients out of solution. So by the same token that when you measure phosphates, you can measure a 0 phosphate level on a green pool because it's inside the cell walls. The same applies to CO2. It's inside the algae colony. So when I took the pH probe, the little digital one, the pH of that green pool was 10.4. 10.4. I mean, I never would have thought that it could have gotten that high. And that's because algae had consumed so much CO2. That's what raised the pH. So the pH was so high, Cal Hypo, the calcium had no chance of going into solution. That was a lesson learned. So you actually have to drop the pH considerably right before you chlorinate for this to be a success. Not so much because the pH controls the strength of your chlorine if there's CYA in your pool. That's not it. It's to make sure that your chlorine goes into solution and actually works.
We did liquid chlorine this time around on this last week. And just so everybody knows, we're in North Texas and this market's not too keen on liquid chlorine or more of a Cal Hypo trichlor kind of market for shocking and sanitizing, which there is bleach. It's getting more readily available and accepted. So we decided to do liquid this time around and it was great. Like you said, it clears, it doesn't cloud. It's awesome. It was good for the cleanup. It was really good for the cleanup, I will say.
That's my preferred method. Absolutely liquid chlorine. That's the fastest way I've been able to do it. I've used Cal Hypo. One time, early days before I understood what different types of chlorine were. I mean, we're talking 3-4 years ago. All the customer had was granular dichlor. And eventually it worked, but we found that stabilized chlorine like dichlor or trichlor is not optimal for this because, again, the CYA ratio matters a lot. So you don't want to just dump a ton of stabilized chlorine into a pool because your CYA is going to jump very rapidly. So keep that in consideration.
Which kind of brings up a note. I had a friend yesterday telling me that her sister had a bucket of chemicals explode on her face.
Oh my gosh.
She was trying to beat the weather coming in because it was raining here. So she had a bag of shock. She had 2 different bags of shock she thought was Cal Hypo.
No.
Mixed them in the bucket and it blew up on her face, burned her face. The fumes hurt her lungs. Like,
she's lucky to be alive.
Oh, that's what I'm saying. So please do not just willy-nilly mix chemicals here.
Absolutely not. No, absolutely not. And always use caution. Wear protective gear. Wear your safety glasses and gloves. I mean, these chemicals don't mess around.
Well, I told her, I said, she's lucky she poured it in water and mixed it in a bucket because if it were dry and she mixed them together,
boom,
big problem.
Yeah, it could have been.
She said, it basically exploded in the bucket up into her face and the fumes and everything.
Oh yeah. The different types of chlorines do not play nice together. And we went through that in previous episodes as well. That's why. That's a great example and great story. Thanks for sharing that. I got to hear in the show notes, Jared, not that I ever really follow show notes. I kind of feel like that's how I'd be. Yeah, I mean, well, that's how I kind of feel like if I were giving a big speech with a teleprompter, I'd probably have like 5 bullet points on it. So it's a more natural way to speak, I guess. But I wanted to talk about some of the byproducts and why algicides kind of conflict. But I think that deserves its own episode. Just know, for this process to really work, you don't need algicides, and here's why. The best algicide is chlorine. You're not just going to kill it twice. I mean, you're going to kill it harder. I mean, the key here is to kill it once and then take the nutrients away so that it's slower to come back. Because again, sanitization is just how fast can you kill compared to how fast it can reproduce. Well, if you can cripple its reproduction rate, okay, a great way to do this here is to manage your CYA level. So if you raise your free chlorine level relative to your CYA, right there, you've got some time. Okay,
Well,
that's a good thing.
the way I look at it is, I agreed. You don't need an algicide. And obviously everybody understand they sell algicides. People sell algicides because they do work. We're not saying they don't work. Okay. It's just our
Oh, they'll
approach
kill
is,
algae. Yeah, they'll kill
yeah,
algae for
absolutely. It
sure.
works. Our approach is that we want a more proactive approach for the long-term chemical efficiency of your chlorine so that it works better and easier down the road.
Mhm.
And let's say you're doing a green pool cleanup with an algicide. That's great. It'll clean it up, no problem. But you're not dealing with the root of the problem.
Mhm.
Okay. You're still going to have chemical efficiencies that you're going to have to overcome with all these chemical, conflicts that he was talking about that deserve another episode. You're still going to have those conflicts even after this pool clears up.
Mhm.
So our approach is to get to the root of the problems,
Right.
which is, making your chemical chlorine more efficient, getting rid of non-living organics. So using enzymes to digest these oils, hairsprays, lotions, sunscreens, get phosphate remover in there to make that chlorine more efficient. Manage the pH. If your cyanuric acid is 150 parts, don't dump a bunch of chemicals in there. Drain it halfway, drain it all the way, refill it up, get a good working base to move forward with.
Mhm. Well, don't drain it all the way without a professional. Like you said, we don't want a pool to float out of the ground. Okay. If you're going to drain more than a foot or two of water, have a professional do that. We know that most of our audience listening to this are homeowners. So I hope you take this advice in stride. Uh, please don't risk it. The hydraulics of draining a pool are, they're real. And I've seen pools float out of the ground. I know Jared has as well. And that is a very expensive
Go ahead and
problem
search
to
in
have.
your search box, pools floating out of the ground.
Yeah, you'll see them. Not a good problem to have. So we'll put it that way. But in order, the sequence here, if you do have a pool that's taken over by algae, is to first get as much debris out of the pool physically as you can. That means netting. That means brushing. That means vacuuming. Do whatever you can. Even if you can't see the bottom of the pool, do whatever you can to get the big debris out and then switch to a vacuum. Do as much material removal as you can. This may take opening up the filter, spraying off the cartridges, cleaning the filter the first time. Don't worry, it's going to happen again. Backwashing a sand filter, things like that. That all needs to happen. Strainer baskets, skimmer baskets, clean them all out. Then brush like crazy. You want to stir this up, right, Jared?
I would like adding chemicals, then brushing like crazy. That way you're giving it an even mix all in the water.
One or the other. I usually brush first.
You can never brush enough, in my opinion.
Yeah, well, I brush first, and then I add the acid, and then I add the chlorine, and then I add the phosphate remover, all within a couple minutes of each other. So I'm diluting acid in a bucket of water to get the pH down, and then I'll go around the perimeter with the acid, and then I will go around with liquid chlorine. I mean, for me, I'm double fisting. I'm taking 2 gallons and I'm just pouring it as I walk around. You don't want to be at waist height here or shoulder height because it's going to glug and it's going to splatter. I'm reaching down. I'm within a few inches of the water. I'm putting chlorine directly into the pool around the perimeter. And then
I think on
immediately
a green pool cleanup, a good rule of thumb is probably 1 to 2 gallons per 10,000 gallons of water.
That's about right. Yeah, because you want to raise it somewhere between 5 and 12 parts per million is usually plenty. You don't need to go crazy. You don't need to nuke it because you're only going to kill it once, really, if this process is done correctly. Immediately after the chlorine is PR 10,000, 1 quart per 10,000 gallons. And now, if you've ever used PR, for the industry pros that use our product already, you're thinking, oh my God, 1 quart? Yeah, that's way more than you would usually use. But normally, you'd use 2 ounces per 10,000 gallons at a time, maybe up to 4.
Well, and part of it too is the PR 10,000 acts like a flocculant, kind of, where it'll sink. It'll help sink particles to the bottom so that the cleanup process is a little easier.
Well, that's true. But the other problem is you don't know what your what your
True. No
phosphate
idea.
level is. You just know it's high because even if you test it, as the photo illustrates behind me, really glad we came back to this because I said earlier we were going to talk about this photo. That's a green pool that tested 0 for phosphates. And that's PR 10,000 dripping into it, clearly clouding up within seconds. So there are phosphates present, but that's following chlorine. So chlorine is already killing this stuff, and we're immediately following that up to take care of the phosphates to get those out.
Next question is brushing it around, getting the pool circulating. When do we add enzymes?
Well, that's a great question because that is the third step. And now there's 2 schools of thought to this, and I've tried both and they both work. So I'm not exactly sure which one I prefer. Normally, you add it the next day. You try to let PR flock everything down. You circulate for a while, 10, 15 minutes to get all the chlorine circulating, and then you shut off circulation and let everything flock. That's one school of thought. Okay, because it'll drop to the bottom. You can vacuum it the next day, or at least it should drop to the bottom. It makes the cleanup a little easier the next day. Or you can add enzymes about half an hour to an hour after you add the phosphate remover.
That's the one I like. I like getting the chemicals in there, brushing it around. After I do that, brush it really well, get everything mixed up, get the system running, get it circulating. And then generally speaking, about 30 minutes to an hour later, before I'm leaving the job, I'll add enzyme.
Now, I wish I could show video. I don't want to share my screen because the people listening are just going to be like, well, this sucks. I can't even see what he's doing. These will be on YouTube eventually, but that takes so much more time. It takes so much more editing of the video. There's footage that I have of a totally swamp pool. And the problem was I got the call after like 4 or 5 days of the service professional who knows what he's doing was throwing everything that he could at this pool. And it just kept going back to where it was. It would not flip. It would not clean up. He couldn't break it. And so we came over and we did our process, and it broke it within 20 minutes. You could see the color was changing and all sorts of stuff. And so I said, you know what? I want to put CV700 in it right now. And I purged it. The organics that floated out of the black lagoon at the bottom of that pool that you just couldn't see because the pool was so, opaque and dark green, the stuff started floating up, and it was about a 1/4 inch of organic sludge foam. I don't even want to know what it felt like because I didn't touch it. And you could just watch it working its way slowly into the skimmer. And it was so disgusting. If you've ever seen our videos on filter purging, where we go into like a big commercial pool filter and we clean that up and the organics float to the top and then we backwash them out, it was like that through the whole pool. So you don't know what organics lurk in that pool, but I can guarantee you, if you have a green pool, there's a lot of them. You can't test for them.
Think about it.
There's a lot of them.
Decomposing leaves and pine needles and, things fall in there. And
Yep. And a lot of chlorine is going to get used up fighting that stuff, not killing. And so this process has a different philosophy rather than just go
back
ahead.
to that point of timing. That's why I like adding it before I leave, so that I'm not letting another day go by with inefficiency. So getting it in there sooner before later is better, in my opinion.
And that's fair. But again, the other way of looking at it is, all right, I'm going to be back here tomorrow morning. I'm going to shut off circulation and flock this stuff out. Both can be very effective. But yeah, I mean, I'll go with what you're saying. Go ahead and put it in the same day, but give it about 30 minutes to an hour after the chlorine, because you don't want the chlorine to fight the enzymes in such high levels. I mean, if you're over 10 parts per million, that can start to be a detriment. If you're under 10, no, they're going to be totally fine. But if you wait 30 minutes to an hour, trust me, your chlorine level is not going to be 10. It's going to go below that.
It's being used rather quickly.
Extremely quickly. It's not going to necessarily get used up, though, because you followed it up with a phosphate remover and you are brushing things around, and the process is going to be much easier. So if I could describe the difference between the Orenda green pool cleanup and the traditional one, it'd be like this. The traditional green pool cleanup is kill it hard, kill it again, kill it, kill it, kill it, kill it, kill it, and just hope that you finally break it. Throw as much chlorine and algicide as you need at the problem until it breaks. Is that a fair statement, Jared?
Mm-hmm.
Ours is kill it once, remove its nutrients, and remove the organics afterward. If you do that, the reproduction rate of it coming back is significantly slowed down. So you don't need nearly as much chlorine, and you can break it very quickly.
Let's start that over. I don't like saying nutrients after that. Say increased chemical chlorine efficiency.
How about you describe it?
Well, you got to lead back off.
Okay.
You were on the.
I know. All right. So that's the traditional way. Jared, what is the Orenda way?
The Orenda way is get chlorine in the water because it's the best algicide. Follow it up with a phosphate remover to increase that chlorine efficiency. And then 30 minutes to an hour later, get enzyme in there to help out with the non-living organics and oils.
And
Brush
that way,
it around, circulate the pool, get it going.
And that way, everything's addressing what it's meant to address instead of just relying on chlorine to do everything.
Yep.
It's a much more efficient way to handle this. So as a total recap of how can I fix my green pool, right? You got to figure out, why is your pool green? So one of the ways is if you have too much alkalinity relative to your calcium, or in other words, you just don't have nearly enough calcium. All right. You typically want a 3-to-1 to 4-to-1 ratio of calcium to alkalinity. And the way to correct that is simply add calcium and maybe reduce alkalinity. That can be done pretty easily. If it's copper, Jared, we got to find the source of copper. We have to stop that source of copper. All right. So if it's trichlor tablets in the skimmer, we got to stop that practice immediately. And then we can use something like SC1000 or another sequestering agent, metal filter to get the metals out. We are not a stain removal company. So if you do have the stains, you got to look elsewhere to figure out how to get those stains removed, but you can use SC1000 in conjunction with a citric acid, which can help lift those stains. It's just not really what SC1000 was made to do, but it will help. And then to algae. Jared, recap algae.
Algae is just a phenomenon where we're trying to fight our growth rate versus the kill rate of our chlorine, and it was a losing battle. And we are trying to increase that efficiency for chlorine to do its job better. And like I said, it's get the chlorine in the water, make sure your pH is within range so you don't have a clouding issue, and getting the phosphate remover in there to help the chlorine efficiency, follow it up with an enzyme and brush, let it circulate, come back the next day. And, like I said, you're also going to have to make sure the filters are cleaned, because it might take 1 or 2 times to clean that filter to get this thing turned around too, because it'll load up pretty quick.
That's a good point. As we close out here, what are people going to expect if they do our green pool cleanup? They come back to the pool. What does it look like?
It'll be clear, probably a little cloudy, but blue. So circulation is key.
So filter pressure is going to probably be through the roof. There's
Absolutely.
going to be a lot of stuff on the floor. You're going to have to vacuum, clean the filter.
Backwash.
Backwash, whatever it is. So consider that you're taking a lot of things that were not supposed to be in that pool out of the pool. So it's not just a chemical remedy. There are some physical things that need to be done as well. And I think that's it. I think we've covered pretty much the bases here. Anything else, Jeremy?
I don't know. I agree, but I don't know if you've ever mentioned it on a podcast before, but everybody needs to do themselves a favor. And if you haven't seen Eric sing the song about phosphate remover, you really should do yourself a favor and go find it. What's the video called again?
You went there.
I did. It's amazing.
Okay. I'll have you know that I didn't invent that Super Bowl commercial. All we did was parody that Super Bowl commercial.
And it was great.
And
you want a good laugh, go find it.
Yeah, you'll find it on our Facebook. And I have no regrets. I have no regrets. None. All right, everybody. Thank you so much. I can't believe you brought up that video. Thank you so much for listening to the Rule Your Pool podcast. I'm Eric Knight with Orenda, and with me as usual, Jared.
Thanks everybody.
You got me. Thanks again for being here.
Thank you for listening to Rule Your Pool, a podcast by Orenda Technologies. For more information on what we discussed in this week's episode, check the links in the description or visit www.orendatech.com.
I hope you find this show valuable enough that you tap that subscribe button and share it with your friends. You can also like us on Facebook and social media. And with our help, you'll be able to rule your pool without over-treating it with chemicals and wasting money. I'll see you next episode.